Your air conditioner has been lying to you your entire life, not in a complicated way, in a simple, fundamental way that changes how you understand every summer, every electricity bill, and every moment you've stood in front of a vent, wondering why the room still feels warm. Here's the thing. Your air conditioner doesn't make cold air. It never did. It can't. Cold isn't something a machine can manufacture and pump into a room. That's not how physics works. And by the end of this, you'll understand exactly what your air conditioner is actually doing inside your walls right now, why your house fights back against it every single second, and why a $2 problem can cause the whole system to collapse. Because once you see this, you'll never think about your thermostat the same way again. Let's start with something you've probably never questioned. You walk inside on a brutal August afternoon. The air hits you, cool, still, almost immediate relief. And your brain files that experience under one simple label. The AC made it cold in here. Reasonable, logical, and completely wrong. Your air conditioner does not generate cold the way a heater generates heat. A furnace burns fuel and creates thermal energy from scratch. Your AC does not have an equivalent process running in reverse. There is no cold being produced, no chill being manufactured somewhere in that metal box outside your window and piped into your living room. What's actually happening is something far stranger, and honestly, far more interesting. Your air conditioner is a heat removal machine. Every single second it runs, it finds heat inside your home, grabs it, carries it outside, and dumps it into the outdoor air. The coolness you feel is not something being added to the room. It is what is left behind after the heat has been taken out. Think about a sponge. A sponge does not create dryness. It absorbs water and carries it away. The surface feels dry not because dryness was applied, but because wetness was removed. Your air conditioner works on exactly the same principle. It does not create cold. It absorbs heat. The room feels cool because the heat is gone. That is the whole game. Understanding that one shift from creation to removal unlocks everything else. But here is where it gets strange. Before you can understand how heat gets removed, you need to understand what heat actually is. This is where common sense leads most people in the completely wrong direction. Heat feels like a thing, a substance, something that fills a room and sits there, heavy and oppressive on a humid afternoon. By common sense, cooling a room should mean adding something cold to cancel it out. Cold in, heat neutralized. Simple trade. But that is not what heat is. Heat is not a substance sitting in your room. Heat is motion. Specifically, it is the speed at which molecules are moving. Hot air is not different air. It is the same air, with molecules vibrating and bouncing faster. When your room feels warm, that is not a material that needs to be replaced. It is energy that needs to be moved. And here is the physical law that your air conditioner is built entirely around. When a liquid evaporates, it absorbs heat from whatever is surrounding it. You have actually felt this your entire life without realizing it. Think about rubbing alcohol on your skin. The moment it touches you, it feels cold. Not because the alcohol is cold. Often it is sitting at room temperature. It feels cold because it evaporates almost instantly, and as it converts from liquid to gas, it pulls thermal energy off your skin to do it. Your skin loses heat. You feel the chill. That is not a trick. That is a fundamental law of physics. Evaporation costs energy, and it collects that energy from whatever it touches. Your air conditioner runs that exact process, continuously, in a sealed loop, inside your walls, inside your ceiling, inside that humming box, outside your house, right now. So let us follow the physical journey, step by step. This is where it gets genuinely remarkable. Inside every air conditioning system, there is a fluid called refrigerant. You may have heard the name. Most people have no idea what it actually does. Refrigerant is not a coolant the way water cools an engine. It is a working fluid. Its entire purpose is to change states, liquid to gas and gas to liquid, over and over again, millions of cycles, carrying heat from one place to another as it goes. Here is the loop. The refrigerant starts as a cool, low-pressure liquid. It flows into the evaporator coil. That is the component sitting inside your home, usually above your furnace or inside your air handler. Warm air from your house is blown across this coil by the blower fan. The warm air touches the coil. The refrigerant inside is cold enough that it begins to evaporate. As it evaporates, it behaves like rubbing alcohol on skin. It absorbs heat from the surrounding air. The air blowing across the coil loses heat, and it comes out the other side cooler. That is the air flowing through your vents. That is what you feel. Now the part most people never think about. The heat did not disappear. The refrigerant absorbed it. Now the refrigerant is a warm gas, loaded with the thermal energy it just pulled from your home. It has to go somewhere. So the refrigerant travels outside. It reaches the compressor, a pump that pressurizes the gas, which raises its temperature even further. Then it flows into the condenser coil, the set of fins on the outside unit you have walked past 1,000 times without a second thought. A fan blows outdoor air across those fins. The hot refrigerant releases its heat into the outdoor air. It cools down, condenses back into a liquid, passes through an expansion valve that drops its pressure back down and starts the entire loop over again. In, absorb, out, release, repeat. Your house feels cooler because a fluid is continuously shuttling heat from inside to outside in an endless loop, powered by the compressor. There is no cold being made. There is only heat being moved. Now here's the part of the story that nobody tells you. It completely changes how you understand that electricity bill. Your house is fighting back. Every wall, every window, every gap around a door frame, every inch of your roof baking under direct sunlight, all of it is constantly conducting heat back into your home. Physics is relentless about this. Heat always moves from warmer places to cooler places. Outside is hotter, inside is cooler. So heat is always trying to flow inward. Always. Your AC is not just cooling your house once and holding it there. It is running a continuous battle against the entire thermal mass of the outdoor environment. Every second it cycles, your house is absorbing heat through every surface it has. And your AC has to remove all of it. Think about it like a leaking boat. You are not bailing the boat once and then relaxing. You are bailing continuously because water is always coming back in. The moment you stop, the boat fills. The moment your AC shuts off, the heat starts reclaiming your home. That is why a poorly insulated house does not just feel slightly warmer. It overwhelms the system. Too much heat is flowing in through the walls and roof for the AC to keep removing fast enough. The compressor runs longer. The electricity bill climbs. The house never quite reaches the temperature on the thermostat. And your roof is the worst offender. A dark shingle roof on a summer afternoon can reach temperatures of 150 degrees or higher. That heat conducts directly into your attic, and from your attic into your living space. It is a constant, massive source of thermal load, pushing against everything your AC is trying to do. Insulation is not just comfort. It is the thing that determines whether your AC is fighting a manageable battle or a hopeless one. Now let's talk about the number nobody mentions, because this is where the engineering gets genuinely surprising. Your air conditioner's job isn't measured the way most people assume. You'd think efficiency would mean how much cold it produces per hour. But cold isn't produced, so the real measurement is different. It's called the coefficient of performance. What it measures is how much heat gets moved for every unit of electrical energy the system consumes. In most home systems, for every 1 unit of electrical energy the compressor uses, the system moves roughly 2 to 3 units of heat out of your home. Coefficient tells you how effective that transfer is. That sounds impossible. Getting 2 or 3 times more output than input feels like it breaks a rule, but it doesn't, because the air conditioner isn't creating energy. It is just moving energy that already exists. The electricity powers the pump. The pump moves the heat. The heat is free. It was already there. And here's why this matters practically. When your air filter gets clogged, airflow across the evaporator coil drops. Less warm air touches the coil. Less heat gets absorbed per cycle. The refrigerant does not fully evaporate. The system runs longer and harder to move the same amount of heat. Efficiency collapses. When refrigerant leaks, the working fluid is depleted. The loop cannot carry as much heat per cycle. The system runs almost continuously, and the house still never cools down. It is not that the air conditioner broke. It is that the heat removal capacity of the loop dropped, and the thermal load of the house is winning. A $2 air filter. A small refrigerant leak. Either one does not just slow your air conditioner down. It shifts the balance of an ongoing battle that your system was barely winning to begin with. So the next time you walk into a cool room on a summer afternoon, here is what is actually happening. A refrigerant is evaporating inside a coil in your wall, pulling heat out of the air, molecule by molecule. That heat is riding a chemical loop through your house, up to your roof, out to a box in your yard, and being released into the outdoor air. Your walls and windows are fighting back constantly, conducting heat inward every second, and your air conditioner is removing it just fast enough to stay ahead. It is not cold being made, it is heat being moved, continuously, precisely. Across a battlefield, you have been living inside your whole life without knowing it. Now here is what that actually raises. If heat moves constantly through your walls, your roof, your windows, there is a physical sequence that determines exactly how fast it moves through each one. The answer reveals why some houses cool in minutes and others never quite get there, no matter how hard the system runs. That is the hidden story living inside your walls. And we have already made a video about that.